Figure to the right shows the graphs of the polar curves r equals 2 cosine 3 theta and r equals 2. What is the sum of the shaded region? Okay, so this one's a little bit challenging. So we have our circle, area equals pi r squared, which will be, r will be 2, so 4 pi. But we want to find the area of the petals, the white non-shaded region, and then subtract that off. And that part will be a little bit more challenging. We'll pretty much use our calculator for that. So to start off, just get an idea of what's going on, let's graph this. Whoop. Let's go mode, polar, y equals, and we'll do 2 cosine 3 theta. And then we'll look at the window. Yes, we'll leave that. We'll go from -3 to 3. -3 to 3. The maximum should be 2. So 3 will give us a little bit extra. And we say, whoop, graph, whoop. Seems reasonable. And then we'll trace. No. Second quit. Back to graph. Trace. And we go from 0 to 0.5 theta. So basically 0.5 is kind of like pi over 6. So this region right here, ooh, purple, here is theta equals 0, and here is pi over 6. The graph said 0.5, and pi is almost 3. 6 is 6, so it's about pi over 6. And it is pi over 6, which makes sense because if you look at our equation, 2 cosine 3 theta, that would be 2 cosine of 3 times pi over 6. Pi over 6 is, or 3 pi over 6 is the same as pi over 2. And the cosine of pi over 2 is 0. So it makes sense that theta equals 0 would be biggest, and the first minimum would then come at pi over 6. So the way I'm going to draw a line right here. I went back to purple. Why did I change colors to change to the same color? What I'm going to do is I'm going to find this area right here. And normally when you find area, you think, okay, we're going to do dy dx, integrate along y, integrate along x, but we're doing polar coordinates. And for polar coordinates, dy dx is equivalent to r dr d theta. One thing to remember is when you convert from dx and dy to dr d theta, you have to put in an extra r. There's not an easy way to explain that based on what we know so far. You'll kind of hear sometimes that, all right, looking for, instead of looking for a square like dy dx, you're looking for an arc, and this would be dr, and then this arc length up here would be r d theta, and then that's where you get the r dr d theta by multiplying the two together. That's not entirely true. That's more of a mnemonic, a good way to remember it. But r dr d theta is simple enough to learn that you should just memorize that. It's actually, you're doing change of basis. So we're not going off that far of a deep end here. So we start here with r dr d theta to find our area. But the question then is, okay, what are our limits of integration? So r dr d theta, we're going to go from 0 to 2 cosine of 3 theta. This is going to be the initial r, 0, and this is going to be the final r, 2 cosine 3 theta. And so the idea here is we're basically taking little arc lengths here. And this one will be the theta, and we'll go from 0 to pi over 6. Because all I care about is this section here, then I'm going to multiply by 6. By doing just this small section, I kind of eliminate a lot of the going through 0 and negative values and anything else funny that just kind of might happen along the way. So if you haven't figured out yet, this is one of the more challenging problems you'll get. Being expected to do this in 3 minutes is kind of rough. It is. It's still a good problem to know how to do, but if I came up across a problem like this on the AP test, I'd try for it for about 2 seconds. I'd be like, guess. Okay. So integral r with respect to r would be r squared over 2. So we're left with r squared over 2 from 0 to 2 cosine 3 theta d theta 0 pi over 6, which then gives us 6 integral 2 cosine squared 4 cosine squared 3 theta all over 2 d theta. Then I'm going to use substitution to get rid of that 3 theta. So I'll say u equals 3 theta, du over 3 equals d theta. I just moved the, we take the integral of 3 theta, you're going to get 3 d theta. And then to simplify things, I just moved it to below. So we'll have maybe, so let's see, that'll be a 2. Move that out, that'll be, no, I think I'll leave that like that. Yes. So we'll have 6 over 3, 2 cosine squared u du integral. That becomes 2. And now we have to figure out how to do the integral of cosine squared. And to do that, we'll do a half angle formula. So, yep, half angle formula. One thing you could probably do is actually find the limits of integration by plugging 0 and pi over 6 into u, and then just put this into your calculator and use your calculator to solve it. I'd rather not do that. So we have our formulas: cosine of alpha, cosine of beta, maybe bravo, probably beta, cosine alpha minus beta, a little bit more room, plus cosine of alpha plus beta. Then we have two, I think it's sine, yep, sine alpha, sine beta equals sine alpha minus beta plus, minus, I'm ruining all this, terrible. Focus, cosine alpha minus beta minus, you just change the sign, cosine alpha plus beta. That's just the mnemonic I use. The mnemonic I use is that when you go from cosine to sine, you change the sign. And so much writing. Now, if you're doing this on your own in a timed evolution, like a test, then I would just do the first one and stop there, because since we have cosine, that's all we need. So this would be the formula we're going to use. It's just easier for me to remember it all as one mnemonic. So I remember the top one. Then I remember that, all right, when we change from cosine to sine, we change the sign. And when we have one sine, one cosine, then we change from cosines to sines. Go to green. And then for the double angle formula, we say that alpha equals beta. And then we get the formula 2 cosine, I'm going to use u here because that's what we have, squared, equals cosine of alpha minus beta. When alpha equals beta, that's cosine of 0, which is 1, plus cosine of 2u. Yep. So some people just try to memorize this formula straight off. I try and do it this way just because it's so much more flexible. You can do a lot with that. 2 integral 1 plus cosine of 2u du 2u plus sine of 2u over 2. Again, that's just going to be a substitution. And then this will be from 0. Oh, nope, we don't actually know what it's going to be from yet. And then make sure real quick that, all right, so if we took the derivative of sine, we get positive sine. Check. Yes. Okay. Then convert back to our 3 theta. 3 theta plus the sine of 3 theta over 2. And this will be evaluated from, actually I'll do this, 0 pi over 6. Over here, change colors. All right, we can do this. We can do this. Focus. So we have 3 pi over 6. Yep. Plus sine of 3 pi over 6. There we go. Over 2 minus 2 times 3 times 0 plus sine of 3 times 0, which would be 0 over 2. So this would go away to 0. We're left with this, which is, let's see, 2 pi. So 6 pi over 6, which would be pi, plus, this is sine of pi over 2, which is 1/2. Is it 1/2? I think that's 1/2. Sine of pi over 2. Yes. 1/2 divided by 2, which would be 1/4, times 2, which would be 1/2. Okay? And then on the other one, that just all went out to 0 because 3 times 0 is 0. Sine of 3 times 0 is still 0. Oh. Seems reasonable. Check this out real quick. That'll be 6. That's 2. This will cancel. Yeah, maybe. Okay. And then we already had the 6 here. Did we forget anything? No. Did I forget the 2? I might have forgotten the 2 there. No, I had the 2 up there. This feels okay. Lots of stuff. Lots of opportunity for error. Maybe here. Wait, stop, wait. All right, so when we converted 2u to 3u, this would be 2 times 3u. Darn it. Okay. So what we did here with the double angle formula, this should actually be 6 pi over 6, which becomes sine of pi, which is 0. So we're left with just pi. Boop. Okay, that seems reasonable. So I think that was the only mistake I made. Maybe, possibly. So going back, when we took the integral using polar coordinates of these petals, we got a total answer of pi. So these petals, total area of pi. So area total shaded equals pi r squared, which is pi times 2 squared, which is 4 pi. So area of the circle minus area of the petals, which is pi, which equals 3 pi. 3 pi, using our calculator, on, clear. 3 times 3.1415. I know they have a pi button. It's just 3.1415 is more accurate than I'm ever going to need in life. So 9.424, 9.4245, and our answer is, we even have, right there, which is 3 pi. So the way to solve this one is, there's not a real good, easy way to do it. You can probably memorize some sort of thumb rules for finding the area of petals, maybe. wouldn't bother. This is a hard enough and unique enough question that it's good to know how to solve it using polar coordinates and just working your way through, doing the double angle formulas and such. But, yep, at some point, just guess. Meh. You can rule out this one because it's greater than the area of the circle. And then it's like, well, I got 1 out of 4. And probably it's not this one either. So you might be able to rule it down to 1 out of 3, 1 out of 2. And that's how I would approach this kind of problem.